Participants, welcome to MOOCs on Water Resources and Watershed Management by Wrwm. This is Dr. Harish Gupta, UGC Assistant Professor, Department of Applied Geochemistry, Osmania University. I am sure that you are aware that despite several efforts over the decades, until now, Earth remains the only known planet to harbor the life. And before I start my lecture, I would like to ask you few questions. Have you ever wondered why there is no life on other planets of our solar system? Or what are the life sustaining conditions which make life possible on a planet? In this context, how Earth differs from the other planet of our solar system? I'm sure that you might have thought of this question several times. In this lecture, I am going to address all these questions. The title of this lecture is The Mystery of Earth's Water, Earth as a Habitable Planet. In our solar system, only Mars, Mercury, Venus and Earth are the terrestrial planets. Other planets are known as gas giants or ice giants. Terrestrial planets are close to the Sun. They are small, they are made up of rocks and minerals. They spin slowly, however, orbit the Sun very fast. Among the terrestrial planets, Mercury and Mars are the low mass planet. Therefore, their low gravity makes atmosphere retention difficult. Both planets have smaller diameters. Thus, they tend to lose the energy which was left over during the formation part. That means they are now geologically dead. They lack volcanoes, earthquakes and tectonic activities. These processes are important because they supply life-sustaining material. In addition to it, their atmosphere lacks carbon dioxide, which is important for temperature moderation. Path of all planets around the Sun is not circular. That means every planet's distance from the Sun varies throughout the year. Orbital eccentricity is the difference between a planet's farthest and closest approach to its parental star divided by the sum of said distances. It is a ratio describing the shape of the elliptical orbit. The greater the eccentricity, the greater the temperature fluctuations on a planet's surface. Although living organisms are adaptive, however, they cannot withstand so much variation, particularly if the fluctuations overlap both the freezing points and boiling points of the planet's main biotic solvent, like water on the Earth. If daily and seasonal temperature variations were higher, it may not have complex life form on Earth. However, as the terrestrial or inner planets are close to the Sun, this change in distance is relatively small. Because of Earth's axis tilt, it has moderate seasons as well. It implies little variation in seasonal temperatures across the year throughout the Earth. In the case of Earth, there is a slight variation in amount of the energy it receives from the Sun. Therefore, the temperature variation is also very small. Temperature conditions on the Earth allow majority of water to remain in liquid phase. Now, being a rocky planet, the Earth provides a base for life to flourish and has appropriate atmosphere. Most meteoroids entering in the Earth's atmosphere burn down before striking to its surface. Its atmosphere has peculiar composition, and greenhouse effect of our atmosphere helps in maintaining the temperature of our planet. Therefore, water simultaneously exists in solid, liquid and gaseous forms on our planet. These all conditions make Earth as a perfect habitable planet. Based on the discussion so far, we understand that habitability is a function of a combination of environmental parameters such as temperature, atmospheric composition, atmospheric pressure and the presence of liquid water. This brings out the concept of habitable zone in our solar system, and the bounds of habitable zone are based on Earth's position in our solar system and the amount of radiant energy it receives from the sun. So we can say that the range of orbits around a star within which a planetary surface can support liquid water given sufficient atmospheric pressure is termed as habitable zone. The nature of the habitable zone and the objects within it may be instrumental in determining the scope and distribution of Earth-like extraterrestrial life. I hope that now you understand why life exists on our planet. However, it does not mean that there may not be any life on other planets of our solar system and of our universe. However, the first step is to identify the planets which have optimum condition for life to thrive on it, or they are in the habitable zone of their respective stars.